Welcome back to the Using Python at CHPC course. In the previous video, we talked about running Python on login nodes, which again are nodes that you can use for testing and debugging, but which you should not use for large or long-running computations because they're a shared resource and a limited resource that all users of CHPC systems are accessing. So in order to run on compute nodes where you can run these large or long-running processes, you will need to interact with the scheduler Slurm. And if you haven't seen anything about Slurm before, I'd recommend attending or viewing a recording of one of the Slurm presentations. And we also have information on our documentation. Now, one option for interacting with Slurm that is very user-friendly, especially for new CHPC users, is again open on demand. So this will allow you to run an interactive desktop session or a Jupyter notebook from your web browser. So I'm going to open my web browser here and again go to ondemand.chpc.utah.edu. And from here, I'm looking now at the application tiles here. So I'll start with Jupyter Notebooks. If I click on this Jupyter tile, you'll see that I get asked for a bunch of information about my session here. And these are all of the parameters that Slurm needs to know about my job, as well as some options for loading a custom Python environment. So I'm going to start an example here. If I want to load my custom installed version of Python with my own packages, I'd want to select the custom option here. And then I would need to enter the commands that I would run to set up my environment. So for example, the module load commands or the activate commands for the Conda environment. So in my instance, I'm going to choose module load using Python venv. And so this will add to the Slurm script that starts this session, this command here, module load using Python venv, which should load the Python environment that I created. Now I need to specify which cluster I want to run this on and which partition and account and QoS I want to use for that. And if you're not familiar with all of the options here, I'd again recommend attending one of the Slurm presentations. So Notchpeak shared short is a partition that all users have access to, and it has generally relatively fast turnaround times. So it has a limit on the number of cores that an individual user can use. You can see here maximum number of CPU cores on Notchpeak shared short is 16. And these resource limits allow it to stay relatively responsive, which means you're not going to be waiting in a queue most of the time. Now, since this is just a test, I'm going to only use one core. If you're using multi-processing or multi-threading, you could select more cores. Slurm needs to know the number of hours that your job will run for, the amount of time that your script could take to run, your job could take to run at maximum. So I'm just going to leave this as 1 for here. And if you wanted to request a specific amount of memory, for example, if you need a lot of memory for your job, or if you want to run on a GPU or add some advanced options, you can check this box and add additional specifications here. Now, once you're ready and you've set up all of your parameters, you can just click the launch button, and this will queue a Slurm job. So this will submit a request for resources on the compute nodes. And if I refresh the page here, you'll see there were resources available in Notchpeak shared short, and my job is now in starting mode. If I refresh this again, hopefully before long we should see this change to running. So now it's changed to running, and I can click this Connect to Jupyter button, and this will open a new tab where I'm connected to this Jupyter notebook, and this Jupyter notebook is running on one of the compute nodes at the CHPC. So from here I could create, for example, a new Python notebook, a new Jupyter notebook, and I could run my Python code. So I have an example that my colleague Brett created. Let me pull up some of this text here. So for this example, this is just something I'm pulling from a GitHub repository that my colleague created. I can specify some pairs of states and capitals, and then we have some content in a script here. I'm actually modifying this a little bit on the fly. Sorry if this is a little disjointed. So I'll create a new cell here and I'll add some content here. We're importing this the fuzz package that we saw earlier. This is a package that allows for fuzzy searching. So searching for things that are similar but not necessarily exactly equal. And this is not a default part of the Python language, but because we're using our custom Python environment, this should be available to me. So I'll go ahead and run this cell, and then this one here. And what this is doing is we have a function that gets a score based on some search text and a list or some iterable of values. And then we are searching for the string Virginia in this capitals list here. And we are sorting that, reversing it, and then printing the top 3 matches. So this is something that the fuzz package is helping us with, where we are getting some fuzzy search results. And we can see that we get an exact match to Virginia, a close match for West Virginia, and a okay match for California. So this example is really just to show that we can run a Jupyter notebook through Open On Demand, and we can use a custom Python environment wherein we've installed our own packages. Now the second option for submitting a job to the compute nodes that I'd like to mention is this program called salloc, which is kind of a contraction for slurm and allocate, like allocate resources. And where in the previous example we had talked about how Open On Demand allowed us to choose the options for the slurm job from drop-down menus or by filling in little text boxes on the page, salloc allows us to request these resources with the syntax you see on this slide here. So there are some variables that Slurm is aware of. For example, the maximum time that the job will run is -- time. The number of tasks is n tasks, and similarly you can have CPUs per task. You can also specify the memory, that would be -- mem, and so on. So in this case, rather than filling in options on a form, we are specifying these at the command line. So I have a terminal here where I'm connected to Granite1, which again is one of the login nodes. And from this node, I can run this salloc program. So I'm going to just type what I see here in this screenshot, essentially. So I'll do time, 0 days, 0 hours, 10 minutes, 0 seconds, and tasks 1, mem 4G, 4 gigabytes, account equals notch peak shared short, and partition equals notch peak shared short. And actually I will have to add one other thing here. So I'm going to run this and it's not going to work. It'll say invalid partition specified notch peak shared short, and that's just because I'm trying to submit this from the Granite cluster, whereas notch peak shared short is on the notch peak cluster. So in addition to what you see in this screenshot, I have to add clusters equals notch peak. And so what this is going to do is it's going to tell Slurm that I want computational resources with these parameters, and Slurm is going to try and fulfill that request for me. So now when I run this, this again, notch peak shared short is quite responsive, so I immediately got resources here, and I am now actually connected to this compute node. So you see above I was connected to Granite 1, and this is a login node, but here I am connected to Notch 309. So I am now on a compute node, and I could run my large or long-running computations here. And of course I could load a Python module or a custom environment that I'd set up and then run the Python interpreter. So that is another option for connecting to a compute node. And then once you're done with the resources here, you can just type exit, and this will close your connection. It says it's relinquishing job allocation, so it's giving the resources that I was allocated back to Slurm to give to someone else, and I'm now connected again to Granite 1. Now you can do something quite similar to this with what's called a batch script. So in this case, rather than running the salloc command, you would run sbatch with a script that Slurm would then read. So I have an example here called slurm_script.sh, and this is a bash script. So this first line of this script is specifying what the interpreter for this little script is. So it's saying run whatever userbin env bash evaluates to. And then Slurm interprets some of these comments. So a comment in bash starts with this pound symbol, this number sign. But these comments here are special because they start with this term sbatch in all caps. And the sbatch in all caps is something that Slurm knows how to interpret. And so Slurm is going to read these the same way it read the parameters from the command line for salloc. It's going to set the maximum time, the number of tasks, the memory, and so on and so forth. And then the rest of the script is what's actually going to run on the resources that are allocated. So in this case, I'm running module load python 3 and then python 3 myscript.py. So I'm loading a version of Python and then I'm running Python with a script. Now I would submit this script with the sbatch command. So we saw in the previous lecture that we used the salloc command to get interactive access to resources, but we also have this command called sbatch, and this will take a single argument that is the script you want to run. And this script will run once resources are allocated. So the advantage of using sbatch over salloc is that if you have a job where you don't actually have to interact with it at all, if you just want to run a Python script, for instance, you can just submit it to Slurm with this sbatch command and walk away. Just leave your computer. You don't have to wait for it to allocate resources or anything. This job will just run once there are resources available, and you'll be able to come back after it's run and see any of the output files that were generated. So this is a great option, and what I'd actually recommend if you have Python scripts that don't require any user interaction. So if you have a script that just generates some plot files, or a script that reads some input and creates some output file where you don't actually have to type anything to interact with it, I would recommend using a batch script, simply because in this case you don't actually have to sit around waiting for resources to be available. So these are the three options that I would consider for running on a compute node. You can use Open On Demand. You can use salloc to get interactive resources from the command line, or you can use sbatch to submit a script that will just run once there are resources available.